Okay, here is our sixth video on extraction of roots. This is a long section. Lots of cool math in here we got to go over. Here is another one we can do by extraction of roots, which means, of course, getting the thing which is squared by itself on one side of the equation and taking square roots of both sides. I recommend trying this one by yourself. There's a good chance you can do it. And if you do make a mistake, it's good to know what that mistake is. So let's pause it and try it yourself. And now that you've tried it, I'll go over how to do it. The first thing is I want to warn you of a common mistake. Really common for people to try to use the distributive rule with exponents like the 2 here and do x to the power 2 minus 2 to the power 2, but the distributive rule doesn't work for exponents. This is wrong. And it's a general rule that if you have something squared with plus in it, you can't just distribute the exponent in there. That works when you're multiplying things by a sum of two things, but not with an exponent. Anyway, so let's go over the right way to do this. What I would do is divide both sides by 3 first to get the x minus 2 squared by itself. You'll be left with x minus 2 squared equals 16. And this is a general strategy with extraction of roots, is you want to get the thing being squared by itself and then take the square root. So in this case, the thing being squared is the x minus 2 squared. Get that part by itself. Then we can do the square root of both sides. And that will give us the square root on the left side cancels out. And here we do need to remember there's a plus or minus a square root of 16, which simplifies to x minus 2 equals plus or minus 4. So now to add 2 to both sides, we could just do plus 2, plus 2. But the problem is that 4 plus 2 works differently if you have negative 4 plus 2 or positive 4 plus 2. So we could either write it as positive 4 plus 2 or x equals negative 4 plus 2, and that will give you your two solutions, which are 6 or x equals negative 2. And it's always a good idea to check your solutions by plugging them in and making sure it works out. Okay, here is another example of an application formula that you don't have to memorize, but it is a good one to know. It might help you later if you go into like finance or accounting. And it tells you a way of getting the balance, $A, if it starts at a principal of $P, that's like how much you put in the savings account or the whatever kind of fund this is that's paying some interest. So P is where it started at, and then if the interest rate is R, that goes in there, and the number of years becomes the exponent. I'm not going to explain how all this works right now, or where this equation comes from. For now, we're just going to use it to answer a question. So here is the example, and you can try this one too. You might be prepared for it. But here's a point to pause it and read it or write it down, because I'll start doing it right now. So for part A, to write an expression for the amount of money in Carmela's account after 2 years. So that's going to be, the amount of money in Carmela's account, that's the A. And so that's equal to this P times 1 plus R to the N. The nth power there, and it's given that she invested $3,000 in it at the beginning. That's what principal means, so that's going to be 3,000 for that P there, and it's going to be 1 plus R. We don't know what that is. It just says an interest rate of R, so we leave that as R. But what is the number of years? Well, this one says after 2 years. So that's going to be 2 right here. That's the n. Okay, so that expression, it's an expression in terms of r for the amount after 2 years. And so now for part B, it's saying what interest rate would be necessary. That means we don't know what r is. So that the result of this, the A, is $3,500. So we're leaving r as a variable, and we're plugging in $3,500 into the result. And here, be careful. Don't get the order of operations mixed up. Don't try to square the 1 and square the r. Don't try to multiply by 3,000 first. That would be breaking the order of operations too. So we're going to divide both sides by 3,000. And 3,500 divided by 3,000 will reduce to 7 over 6. Now you can take the square root of both sides to cancel out the squared thing on the right side, which gives you this. And then we can subtract 1 from both sides. So now we have these two things for r, these two numbers. If you want to get an actual interest rate, people usually describe interest rates in terms of like percents instead of these weird square roots. So we need to plug those into a calculator to check. So to do the square root here, we're going to get the square root of 7 over 6. And then get out of that square root with the arrow, minus 1. That's the 0.0801. That's the one on this side here. And if you do this one here, I'm just going to hit second and entry to bring that up. And just insert, with second insert, a negative symbol here. And suddenly this doesn't really make sense. We're saying that interest rate is negative 208%. So this is one that is, when you get a negative interest rate, it doesn't make sense, so we're going to throw it out. So we're going to go with this 0.08, which is usually known as 8%. So you can just say 8% is the interest rate that she needs to, that's what you plug into R here, to make it so this thing comes out to be 3,500. Now here's a couple exercises for you to do on your own. So the first one is to write the formula for the radius of a circle in terms of its area, and then solve that for, so yeah, it should be solve 4r in terms of A. I'll give you a little extra hint here. The formula for the radius of a circle is A equals pi r squared, in case you didn't know that. Now here is for exercise 5. Yeah, just solve this by extracting roots like we've been doing. Just a little extra practice to make sure that it sinks in. And I'll see you in class.